Okay, today we're going to graph by plotting. And to see what the graph or the shape of an equation looks like, we are going to plot points. To find out what the points are, we can substitute in different values of x and find out what the corresponding y value of that coordinate is. And what we get are actual coordinates, x comma y. Okay? And we're going to graph, first of all, this equation y equals x squared minus 4x plus 3. And when we look at this, we're going to graph different values of x. So maybe like x equals 0 we'll start off with. Well, if I plug that in, I get y equals 0 squared minus 4 times 0 plus 3. So y must equal 3 in that instance. Now let's try another one. How about x equals 1? Well, in this case, I get y equals 1 squared minus 4 times 1 plus 3, which is 1 minus 4 plus 3, which ends up being 0. Let's do some other points, because we can see the values of y are decreasing. So let's try 2. So y will equal 2 squared minus 4 times 2 plus 3, which is 4 minus 8 plus 3. 4 minus 8 is negative 4, plus 3 is negative 1. Values are still decreasing, so let's keep going. Let's try 3. So y equals 3 squared minus 4 times 3 plus 3. So y is going to equal 9 minus 12 plus 3, which is going to be 0. Okay, so we're back to increasing again. How about, let's do 4. So y equals 4 squared minus 4 times 4 plus 3. Well, 4 squared is 16, minus 16 plus 3 is going to be 3. So we're kind of back to where we started from. Let's graph these. I'm going to graph them in red and in slightly bigger dots so you can start seeing the shape of this graph. First we start out with 0, 3, and then 1, 0, 2, negative 1, 0, 3, 3, 0 again, and then finally 4, 3. So you can see the shape of this function is a U-shaped or a parabola. So it's a parabola. It's too big for this. And I can't spell parabola today. So, looking at the graph of the function, what values of x make y equal to 0? Well, y equals 0 at the x-axis. So the two values that make y equal to 0 are 1 and 3. Now let's see, what values of x make y equal to 3? Well, that was these points, 0 and 4. Okay? Now let's graph a simpler equation. This is y equals 1/2 x plus 3. So let's graph this equation. Again, we are going to make a chart for x's and y's. Okay? Ooh, breaking news, we have the iPad mini. Sorry, these notifications get kind of funny. So let's figure out a couple points. Again, 0 is an easy one to plug in. So y equals 1/2 times 0 plus 3, which gives me 3. And how about 2? Y equals 1/2 times 2 plus 3, which is just 1 plus 3, which is 4. That gives me 2 points. Do I need any more than 2 points to graph a line? I can do a third for insurance. Let me do 4. So for 4, I get y equals 1/2 times 4 plus 3, which should be 5. Okay, so let's put these points on our graph. We have the point 0, 3, 2, 4, and 4, 5. And you can see this line going like this. So, what value of x makes y equal to 0? Well, that's this value here. Oh, no, we haven't, sorry, I'm leading you astray. We haven't really covered that one yet, have we? So, let's plug this in a different way. To find out what value of x makes y 0, how about I plug in 0 for y equals 1/2 times x plus 3, right? Well, then I can just solve for x, can't I? So I subtract 3 from both sides, and I get -3 equals 1/2 x. Well, multiplying everything by 2, I get x equals -6. So that means 0, -6, 2, 4, 6 should be a point on that line, that point there. And you can see that that is clearly on the line. Okay? What value of x would make y equal to 4? Well, we already solved that one and found out that it was 2. So the value of 2 makes y equal to 4. And again, we can check these by plugging them both into the equation and making sure that we get a true statement. So let's introduce some terms. The point where x makes y equal to 0 is going to be called the x-intercept. Okay? This is called this because this is the point where the graph crosses the x-axis. Very important terms here, so make sure you put these in your notes. The point where y makes x equal to 0 is called the y-intercept, because that is the point where the graph crosses the y-axis. Sometimes these are also called horizontal and vertical intercepts. So this would be horizontal intercept, and this is also called the vertical intercept. Okay? Now, sometimes your equation is not in y equals form, which makes it a little bit more difficult to just put in some x's and get out some y's. So if we want to graph these types of equations, the best thing to do is solve for y first. So we get y by itself, which means we're solving for y. So let's see how we do that. Let's look at this equation here. And if we look at this equation, and I'm going to just move this up and to the right just a little bit so we have some more room to write. We want to graph 2y plus 3x equals 4. And that's all fine and dandy, but it's not solved for y yet. Okay? So let's solve for y. So 2y plus 3x equals 4. Well, I want to get the y by itself, so let's move 3x over by subtracting 3x from both sides. And what I will get is 2y equals -3x plus 4. Now, y still is not by itself, so let's divide by 2. Everything divided by 2. So we'll get y equals -3/2 x plus 2. Okay? So, now we want to graph this. So we have x and y. Easy x to graph is 0, and we're going to end up with y equals 2. And I'm going to pick 2 again for an x so that I have y equals -3/2 times 2, to cancel that out, plus 2, which will end up being -3 plus 2, which is -1. So that gives me the point 0, 2, and the point 2, -1. which means my graph goes like this. Okay? Now let's check this against some other functions to see if these are the same lines. Now we have this equation y minus 5 equals 3 halves times x minus 2. And I want to check and see, will this equation here give me the same graph as this other one? What do? Well, if I want to compare equations, I just solve for y every time. So y minus 5 equals 3 halves x minus 2. Well, I need to distribute my 3 halves, and so I get 3 halves x minus negative 2 times 3 halves is going to be minus 3. And here I've got y minus 5. I'm going to add 5 to both sides, and I get y equals 3 halves x plus 2. Well, lo and behold, these are the exact same equation as we had over here, right? So when we graph it, it's going to give us the same line. Okay? So this is an example of two equations that look vastly different. This one up here looks a whole lot different than this down here, but they're the exact same line. Now let's take a look at a third equation, this one here, 4y plus 6x equals 8. Okay? If I solve for y here, what am I going to get? Well, 4y is going to equal negative 6x, subtracting that over, plus 8, right? Divide everything by 4, I get y equals negative 3 halves x plus 2. Is this the same equation? Well, we can see here, oh, actually, I misspoke on that other one, didn't I? I misspoke. This is the same equation as this one, but this other one here, this one here, was lacking a negative, so it is not going to be the same xy values. It will have a different graph because it does not have that negative. Okay? So the two equations that were the same ended up being this one and this one, but this one looks almost the same, but it doesn't have the negative with the 3 halves x. Okay, so it's not going to look the same. Okay? In fact, let's graph that. Let's see if we can erase a little bit here. Well, maybe not. We won't be able to erase. So if we graph that, I'm just going to graph it really quickly for you in a different color. You can see, so you can see what it looks like. We're going to have this point here be the same. Sorry, this green point here. And then it will go like this instead. So our graph, they'll cross, but they're not the same line. And that is for this function right here. Okay? So notice that each part of the function has a different purpose. Okay? And that negative made a big difference because it made the function slant a different direction. And we'll talk about that in the next lesson. Okay, so here we're going to take another example. Here we have the equation 2y plus 5x equals 10. And I want to find the missing value for each point that satisfies the equation. And the missing value is going to be represented by k. So here I have 0, k. So if I plug in 2k, k is y, plus 5 times 0 equals 10, I should get 2k, not 2x, 2k equals 10. So k equals 5, right? And if we plug in 0, 5, that means the point should really be 0, 5. Into the equation, we should get 2 times 5, which is 10, plus 5 times 0 should equal 10, and it does. Okay, so let's do this one more time. We've got 3 comma k, so we'll have 2 times our y value, which is k, plus 5 times 3 should equal 10. So 2k equals 15, or plus 15 equals 10. So subtracting 15 from both sides, we get 2k equals negative 5, and k equals negative 5 halves. So this point is going to be 3, comma, negative 5 halves. Okay? And finally, the third point, 1/5 comma k. What is that value of k going to be? Well, 2 times k should equal 5 times, or plus 5 times 1/5 should equal 10. Well, that means 2k plus 1 should equal 9. Sorry, should equal 10. I'm getting ahead of myself. Subtracting 1 from both of these, I get 2k equals 9. So k equals 9 halves, which is just 4 1/2. So we have 1/5, comma, 9 halves. So not all the points you get are always going to be integer values. You might have some fractions in there. Don't let that make you scared. So let's graph these points and see what that gives us for the equation, or what the line looks like. We have 0, 5, 1, 2, 3, 4, 5, which is this point here. That's our y-intercept. We have 3 and negative 2 1/2, which is down, oh, this thing is not terribly accurate, negative 2 1/2. That's close enough. And then 1/5, comma, 4 1/2. Just like that. So you can see this line kind of goes like that. If I could draw straight, it would be great. And that is the graph of 2y plus 5x equals 10. Now, in follow-on lessons, we'll tell you easier ways to do this, but this is the basic way to graph points, is to just plug in x's or y's and get out the other part of the coordinate. Those create points, those corresponding values create points, and we graph those points to show us the shape of the function. It works for any function. Doesn't matter how complex it is, it will always work for functions. So if you learn no other way to graph functions, please learn this way. Hopefully you took really good notes throughout this, and I will see you in class.